Okay, wrapping up lesson 10, we're going to talk about graphing rational functions. And essentially what I'm going to focus on in our class, besides all of the things we just did, which is identifying horizontal asymptotes, identifying vertical asymptotes, identifying holes, domain, all of that stuff. But when we go to actually graph them, what I'm going to focus on is translating the two rational functions that we had as base graphs, which were 1 over x and 1 over x squared. So when I am going to ask you to graph a rational function in this class, actually graph the whole thing, it's going to be a translation of one of those functions, okay? So also, it's going to be, these are sometimes a little bit tougher to translate, especially if they have like the 4 in there or the 2. So let's just go through a couple and talk about how to do that. So what we're going to do is we're going to start by identifying the base graph. And in this case, because it's 4 over x, my base graph would be the 1 over x. And now we're going to talk about what kinds of translations do we see. So what does the x minus 1 do? Okay, that shifts it right 1. Okay. I don't have any addition or subtraction out here, so that means it doesn't go up or down. What does the negative sign do? It reflects it across the x-axis. And then what does the 4 do? It's like multiplying the whole thing by 4, so it's a stretch by 4. Okay, now, I didn't give myself a grid here, mostly because sometimes these things are really hard. Oh, that's not very straight, is it? Let's try again. To draw accurately when I have a grid, sometimes the y values are not, they're too big. But this one I think we can do. So let's try to tick mark out about 5 in each direction. And see what we can come up with. So remember, my original 1 over x goes through this 0.11, and then I'm going to kind of draw it in sort of dotted, and -1, and does this. So if I'm going to shift it 1 to the right, the best thing to do is to shift the vertical asymptote. So now, instead of here at 0, it's going to be here at 1. So I'm going to draw myself a dashed line to represent that that is my new vertical asymptote. And then that would place, right, usually my new graph would look kind of like this. I'm just translating everything 1 to the right. But I do need to stretch by 4. I am going to reflect it as well. Get rid of, let's see if I can get rid of just a little bit of this extra stuff. Of course, when I do that, I'm going to get rid of some of my tick marks. So helpful. 2, 3, 4, 5. Okay. So what was here at over 1, up 1 here will now be over 1, up 1, 2, 3, 4. Whoops, I'm sorry. Let me get rid of some of these because they are kind of in my way. So what was, if this is my vertical asymptote, usually I would go over 1, up 1. But now I'm going to go over 1, up 4. That's what my stretch will do. And so now my curve would kind of come in like this. And then I'm going to do the same thing here. What would have been over 1, down 1 will now be over 1, down 4. See how to do that? Stretch I know I haven't reflected yet, but I just wanted to give you that idea of the stretch. So now I'm just going to reflect. So I'm going to move what's here down here and what's here up here. So I'm going to take that, let's see, it's at 2, 4, and I'm going to put it at 2, -4, and draw in my curve here. I have the same horizontal asymptote. And then I'm going to take what was at 0, 4 and put it up, or sorry, 0, -4 and put it up here at 0, 4. And again, same horizontal asymptote. That didn't change because I didn't move it up or down. So now I have my stretched and reflected and translated graph. So that's kind of the process I want you to use. I don't want you to spend time point plotting a whole bunch of points. I want you to know what that base graph looks like and then know what translations are going to do and how they're going to move it. So let's do one more here with number 2. So our base graph in this case, because we have the squared in the denominator, is the 1 over x squared. Because of the +2 in the denominator, it's going to move left 2. Because of the +3 at the end, it's going to move up 3. And then the 2 in the numerator is going to stretch it by 2. So I know that 1 over x squared is always above the x-axis. So I'm just going to put my x-axis down here so I don't have to worry about anything graphing down here. Okay. And now I'm going to do some tick marks. Oops, that wasn't what I wanted. There we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Let's try that. All right, now we know that this originally has a vertical asymptote here at 0. If I'm going to move it left 2, that makes my new vertical asymptote here at x equals -2. We also know that it originally has a horizontal asymptote at x equals 0. Sorry, y equals 0. If I'm going to move it up 3, then that horizontal asymptote is going to come up here to 3. So if that was all that we were doing, if there was no stretch, I could draw my curve in right here and right here, because that's what the 1 over x squared does. It goes right in between these asymptotes like this. The stretch by 2 will just make it, remember, it was over 1 up 1 for our original, over 1 up 1. So it's just going to go over 1 up 2, over 1 up 2. So I'll move over to -1 and go up 2 and draw in my curve here and go over 1 up 2, just kind of try to mirror that on the other side. I mean, it's a beautiful graph, don't you think? The left side's a little wonky, but you get the idea. And that's what I want. I want you to be at the point where you can identify what the base graph is, so what it's basically going to look like, and shift it around, reflect it, and have that intuition. If you can walk into Calc 1 with that graphing intuition, you are going to be in so much better shape than you would be if you were stuck point plotting or relying on a graphing calculator to find this for you. Okay. So if we can't identify, if it doesn't look like it's going to have like a translation of a base graph, then you could, find the intercepts, factor the numerator and the denominator, determine where the asymptotes, holes, and end behavior are. So basically, you could do all the pieces that we've talked about, like finding intercepts, finding holes, finding asymptotes. And that would at least give you some idea of what that graph's going to look like. I'm not going to be asking you to graph those fully. I'm just going to be asking you those kinds of questions, which you can see here in the last set of examples. I've asked you to find some intercepts, find the asymptotes, identify the end behavior. So these are the kinds of questions you would see on, these are not translations, right, of our base 1 over x or 1 over x squared. So I'm not going to have you graphing those fully. Instead, I would have you answering these questions. So take a moment, pause the video, and give those a try. All right, let's check in and see how it went. I guess I should have mentioned that this is all the same function before you started. You probably noticed that as you went along. So again, what we're doing is we're kind of finding all of these different pieces of information that could allow us to put together some picture of the graph. So I know I asked you to start with the intercepts, and you could do that by plugging in x equals 0 to find the y-intercept and y equals 0 to find the x-intercept, but it's always a good idea. And so I'm going to put this little note here to make sure that you simplify the function first. And I'm sorry I didn't say that before you paused the video and started, but maybe you figured it out as you got to part 2, that if you don't simplify it first, you might have ended up with an extra x-intercept, but then that was also something that became a whole later. So it can't be both an intercept and a whole, right? So simplify your function first, which I did by factoring, canceling. So here is the most simplified version of this function. And so if I'm finding intercepts, if I set y equal to 0, I only need to look at when the numerator is 0, because 0 over a number is what's going to give me 0. The denominator being 0 is not going to give me 0. So when I'm setting y equal to 0, I just set the numerator equal to 0. I got x equals -2, so I have 1 x-intercept. And then for my y-intercept, I set x equal to 0, which was either 6 over 3, or in this case, I guess it probably would have been better for me to do, whoops, sorry, trying to erase, which is not working. I would have gotten 2 over 1, which is 2. So my y-intercept is 0, 2. So if I were to be graphing this, I could already start by putting these 2 points on the graph. Now I'm trying to find the vertical asymptotes and the holes, or removable discontinuities. Since I already simplified my function, I can identify that I have a hole right here. So if you didn't simplify in the beginning and you got 2 x-intercepts, but then you came down here and saw this, hopefully you connected those 2 things and took that one out of being an intercept, because it is not going to be one. Hang on one sec. Having a little technical difficulty here. All right, better. You can't have a hole and a point at the same time. So this would be where the hole is. And by the way, you could find the y value of that hole by just plugging it in here. Okay, because once you've factored it out, if you simplify and plug it in here, that would tell you where the y value of that hole would be. And then I take my simplified denominator, I set that equal to 0, and I find the x value where there will be a vertical asymptote. And last but not least, I'm looking at end behavior. Since these have the same degree, I just look at the leading coefficient over the leading coefficient, and that tells me I'll have a horizontal asymptote of y equals that number on both ends. So we could have put those things together, drawn a horizontal asymptote, drawn in this vertical asymptote, drawn in the hole, put these 2 intercepts there, and that would give us some idea of what the graph looks like.